So next part is to connect the circuit using with analog discovery. Of course, this tested with analog discovery board and use breadboard to connect the circuit. So let's see how can we do this. I prepared all the components that are required here. We have a capacitor. The capacitor is very easy to read because you see here it has 1 microfarad. It is written there, 1 microfarad, and this is 50 volts. This is the maximum voltage, for example, with this capacitor. So this is 1 microfarad. So now let us connect the circuit. Let's see. Come on. Okay. So let's try to connect the circuit and see how it looks like. So here we have a capacitor. So we need to add this capacitor to the circuit like this, for example, and then we need to rotate it. And then rotate. So here it is, for example. The capacitor is connected like this. Okay. Then after that, of course, it doesn't matter if you connect it like this or this. Okay. So here it is. The capacitor now is connected to these 2 points. The resistor, okay, this resistor should be connected to the capacitor in series. Then this node is connected to this node. This point and this point are connected here. Let us write the values here and put the values on the top. Okay. And then, so now this is a circuit. It's very simple as this. And then you may need a wire like this to connect the ground. You may need it or you don't need it. So if you want to add it, that's fine. So this will be your ground. It's connected between the second leg of the capacitor. Okay, so now we have circuits similar to this one. Now we need to add the source. The source is this yellow and black. So this will be channel number 1. So you add it here, for example. You can add it here. Okay, so this is the input, the source. This is the source. So this will be channel number or the voltage Vn. Vn is here. Okay, so now this is the voltage. You have to set the wave generator, and this will be the input. Okay, then we need channel number 1 and channel number 2. Channel number 1 will be connected across the source. Then it will be here. This is a positive, will be here. And the negative, which is the orange with the white strip, will be here, for example. So now this will go to channel number 1. Channel number 1. Channel number 2 is the voltage across the capacitor. Then we need to connect it, for example, here and here. So this will be channel number 2. So this is the blue connected here. So now I believe that the circuit is ready now. The circuit is supposed to be ready. So when we look at it, it looks similar to this one. Okay, this is how we connect the circuit. Okay, so now let us open waveforms, and then we connected, of course, the analog discovery board on the circuit. Then we open a wave generator. What we need to do is to do what here? We need to set this value. So let's go here and see what we have. Let's open this. Okay. You see, we selected this this square wave. Okay, and they have here 100 hertz, 2.5, 2.5. Why? I don't know. Let's see here. Why we have these numbers here. What we need is 5 volts and 0, 5 volt and 0, and so on. Okay, and I did not mention anything about this 100 hertz or anything. So what we need here, let's see why we have these numbers. Okay. First, I need a pulse. That's fine. Next, we need to decide what's the frequency. The frequency is 1 over the period. The period is 10 milliseconds. So 1 divided by 10 milliseconds. Okay, 1 divided by 10 milliseconds, which is 0.01. So you can make it like this. You can 1 over 10 milliseconds, which is 0.01. So what is the frequency? Is 100 hertz. 100 hertz. 1 divided by 10 milliseconds. 10 times 10 to the power of negative 3. So it is 10 to the power of negative 2. 1 over 10 to the power of negative 2 is 100. So this is a frequency. Okay, so this is number 1. Number 2, the amplitude. The amplitude, this amplitude is the top and bottom. So 2.5 and 2.5. So 2.5 and negative 2.5. Okay, so that's fine. So now we have, let's make it like this. Let's put this offset 0. So you see it is 2.5 up and 2.5 down. Then the range is 5 volt. From bottom to top is 5 volt. But what we need here, we need 0 to 5. We don't need negative 2.5 to positive 2.5. We don't need this. Okay, so what we need here is to shift the whole signal up by 2.5. So here it is start from negative 2.5. You want to move it up 2.5. That's why we added this offset by 2.5 volt. Now, if you look at the signal is from here it is positive 5, and here it is 0. And this is what we need. So now it is ready. We need to run this. We need to run. So now we have the source. We set the source. Next, we need to go to waveforms again and open the scope. So this is the first part here. Second, we need to see the result on the scope. So open the scope. Let's see how it looks like. Okay, this is first. This is a previous result. Then you need to run. Okay, so when you run, sometimes you need to hit auto set, and if you don't want to hit auto set, that's fine. Okay, so here you see the input, which is channel number 1. This is the input 5 volt, and the output here. This is the voltage across the capacitor. The voltage across the capacitor in the blue. Okay, you can set, of course, the values here. This is only one period, so if you want to make it 2 milliseconds, you will show 2 periods, and you can move this one here to start from 0. You can move it like this. So now I have 2 periods. In the slide, I have only 1 period. That's fine. Okay, you can play with it as you like. And make sure that the channel number 1 and channel number 2, they have the same range, 2 voltage per division, 2 voltage per division, because you want to compare. So what you have here, that the capacitor is charging until it reaches the maximum. Oh, come on, here is the maximum. Okay, and if you want to find the time constant, here is a little bit, I don't know how, is there any easier way to do it, but what I am doing here is just I click this blue, okay, and then try to find the value that has 3.15. So here is 3.6, for example. Let's go back a little bit here. 3.3, okay, 3.2, 3. Okay, so we need to go up a little bit. There it is, very close. Or this one here. Okay, this is very close to it. So now 3.18, very close to 3.15. Then the time constant here is what? Is 940 microseconds. 940 microseconds. Okay, or come on. Okay, yeah. It's almost. Oh, come on. It's very hard to select. Here it is, for example. 940 milliseconds, microseconds. Okay, so in B2Spice it was 996. So 96 to 40, this is microseconds. So they are very close to each other. There's no problem. Okay, so this is a time constant in in analog discovery board. Okay, then what we need to do next is to do what is to connect a resistor. Remember, we need to connect another resistor. So we have to connect the resistor to the circuit in parallel. So now I connected this resistor. Once I connected, you see it happened here that changed it to directly here. So if you want to stop and run it again, it will show you the same result. So you see here the voltage is across the capacitor is moving from 0 to almost, come on, to 2.5, and then after that start discharge, and then charging to 2.5 and then discharge. Same curve that we had in P2 Spice. Okay, so and of course it is the same time constant. So let's see what we have in the slides. So once you hit the scope, you will find this value here. You just need to run this. Okay, sometimes you need to hit auto set if you want, and you set these values. You will get this curve here. This is the voltage across the capacitor. Okay, and as I said, you have to try to find the point that's 3.15, and find the time. The time will be the time constant. Next part, we need to add this resistor. How we add the resistor in parallel? Simple, very simple. So here is the resistor. You can just add it like this. You can go and try to find place. We need to add it to this one here. Okay, and this one. For example, you can do it like this or like this. So now the resistor, this second resistor, which is 1 kilo ohm also, is connected in parallel with the capacitor, because they are connected from here and connected from here. This is all what you have to do. This is all what you have to do. And then after that, you open the scope again, and this is what you will get. This is the answer that you will get. As I said, it will charge, the capacitor will charge to only half of the maximum, which is 5 volt, half of the source. Why? Because the resistor, the second resistor, is acting as a voltage divider. To this part here. No, this one here is okay, has no relation. Okay, so this is the end of this experiment. Then all what you have to do is just try to go through all the steps and write the steps and support your writing with pictures from your circuit and the results. Thank you very much, and I hope that you enjoyed this this lab. And if you have any question, you are welcome to ask. Goodbye.